Okay, I just want to review different ways to compare rates. We can, or ratios, we can compare them finding the common denominator as if they were a fraction. We can change them to a decimal, or we can use rate tables. So I'm just going to quickly kind of review this because we have done this before. Okay, so if I have 4 over 9 and 3 over 7, okay, it's 3 to 7, and I want to find a common denominator. I know that both 9 and 7 go into 63. So that is a common way to, I know that they're going to have common denominators, which means I'll be able to compare. Okay, so this is going to be times 9. This would be times 9. This would be 27. This would be times 7. This would be times 7. 28. And look how close they are. But I I can tell, because they have the same denominator, that 4/9 is greater than 3/7. Okay? The other way I can do it is I can divide them and find the decimal. Remember that 4/9 is 4 divided by 9. So it's 9 divided into 4. Okay, and I have, this would be 4, 36, 4, and I know this is going to be 0.4 repeating. And if I do 3 divided by 7, I have 3, nope, 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 nope. Back. 4, 28, 2, 0, 2, 14, 6. But I already know that 0.44, right, because this would be repeating, is going to be greater than 0.42. So I can find a common denominator, or I can find a decimal equivalent. Okay, the other way I can do it is by doing a rate table. And in this case, it is definitely not the shortest way to do it, but I do want to go over rate tables. So I'm just going to go ahead and I'm going to show you this way of doing it. So I have 4 to 9, and I am going to scale them up to 2, 3, 4, all the way up to 10. This would be 8 and 18. This would be 12 and 27, 16 and 36. 5 times 4 is 20. 5 times 9 is 45. 6 times 4 is 24. Let's get that a 4. 6 times 9 is 54. 7 times 4 is 28. 7 times 9 is 63. 8 times 4 is 32. 8 times 9 is 72. 9 times 4 is 36. 9 times 9 is 81. 10 times 4 is 40. 10 times 9 is, let's make that a 40, 90. Okay, so there I have a rate table scaling up so I can see. I'm going to see if any of these compare to the 3 to 7. So 3 to 7, 2 times 3 is 6, 14, 9, 21, 12, 28. 5 times 3 is 15. 5 times 7 is 35. 3 times 6 is 18. 7 times 6 is 42. 3 times 7 is 21. 7 times 7, 49. 3 times 8 is 24. 8 times 7 is 56. 9 times 3 is 27. 9 times 7 is 63. 10 times 3 is 30. And 3 times 10 is... And now I'm checking to see if any of these have a common denominator, a common basis to compare. And here's this. 27 out of 63 and 28 out of 63. And so here's a way to compare using rate tables. You know, obviously, certainly not the quickest. But I did want to get rate tables in here because you will be comparing ratios and rates using tables. So I just wanted to get another opportunity to have you see what that looks like. Okay, good deal.